Ideas about mining user interactions on mobile devices, specifically ones where touch interactions are the central use. And this work is done in collaboration with Abdi Ghani, who's a postdoc at CMU. So in the past, recently, so just in September, the amount of activity that of web browsing that's done on a mobile device is about 12.1%. And this is up from about half of that from a year ago. So mobile browsing is growing quite rapidly. And there are a lot of applications in using people's interactions as a signal for their interest on web search or for relevance labels and information retrieval. For example, in a lot of click models, so models where you take into account which search results people clicked on, search engines will take that data and use it to label search results as relevant or not for users. And additionally, for some work I've done before on mouse cursor interactions, where you can track where people are moving their mouse on the page, the website can actually figure out, give it a good idea based on how they're moving their mouse, where people are looking on that page. So these are kind of useful signals that are sometimes not available on touch devices. So the question is, can touch interactions be used in a similar way? And the main difference is that on touch devices, you don't have a mouse cursor to move around, so you don't need to kind of control the cursor, and so things might be slightly different. And in practice, when people are using a mobile device, people touch differently, right? So the touch events are usually done as gestures. So there's examples of people using their fingers to pan on the page, to pinch to zoom, or double tap to zoom. So often when people are interacting with a website on a mobile device, they're doing gestures to adjust where people are looking. So just using these touch events as the same way as we've been using before is a little problematic for a couple of reasons. One is that the touch coordinates don't necessarily correspond to where people are paying attention. So when people are moving their mouse around, there is some kind of relationship between where they're moving their mouse and where they're looking. But when people are using touch devices, often you're not looking where you're touching, right? You're maybe pinching to zoom and you're looking in between where you're pinching, or you're kind of panning and actually, when you pan, you don't really want your fingers to obscure where you're looking. So that's one problem. Another one is that when we tested a bunch of different browsers, all the mobile browsers do the sampling of which touch events to report back to the client differently. So the W3C touch standard leaves the sampling rate up to implementation of the device. And so different browsers and different phone manufacturers will basically sample completely differently. And so it becomes really hard to replicate which gestures the users made. So these are two challenges. But one idea we had is we can actually just focus on the viewport. So every time you move, when you touch the screen, often you change what's shown on the screen. And so you can actually track the visible area on the screen when it changes. So this can be done by just looking at the bounds of the viewable area whenever you see a touch event. And on mobile devices, when the screen is small, these viewports are even more important because you can't see the whole page on your mobile device. Like at home on my computer, I can see the entire Bing search results page without having to scroll. But when on my phone, I have to kind of narrowly go between maybe 2 or 3 results and kind of zoom in and out if I want to see images well. So the viewport is actually even more important on these smaller devices. And another thing is that the degree of zoom shows interest. So when you start off on the mobile devices, often you start off look at the general layout of the page, and so you're not really paying attention to anything specific. But when you zoom in, that's when the focus changes to a small part of the page. And if the website is tracking this information, then you can tell that this particular part of the page is more interesting. So this leads to a few applications. One is that we can generate heat maps from the viewport. And so rather than what's typically done, you generate heat maps from maybe coordinates where people are looking or where the mouse is, you're actually generating it from viewport bounds. So it would kind of look like this over here. Well, it looks a bit yellow, but basically, if you can take the viewport and overlay it onto a website, and you can see, the more viewports are overlaid on a particular part, the darker it is, and you can see kind of which areas people have been focusing on a page. And the other application is using this data to help search models. So a lot of search models will take into account what search results people looked at, right? So then you will have some information about what they examined. So previously, what people looked at was kind of inferred from the click data, but now you can have a better idea which search results people focused on, and from those, which ones they maybe looked at and didn't click. So it's some additional information there. So just wanted to propose a few research directions about this area. One is maybe can we categorize touch interactions? So look at the different ways people touch the mobile device and determine context, like are they maybe laying down while they're using the device? What situations are they using? And maybe that we can use that in addition to just looking at the viewport. But the other problem is also how can we apply this viewport data? So how useful is it in information retrieval? So there's some proposed applications that I talked about, but we haven't actually done those in a systematic way on a real search engine. So those are just our ideas, and so welcome any comments if you have them. Thank you.